All right, this is section 10.3. Geometric sequences and series. We have first a geometric sequence. So a geometric sequence is a sequence in which the ratio, okay, so it implies multiplication or division between successive terms, successive just means in a row, is a constant called the common ratio, denoted R. So the first thing we're going to do is determine the common ratio and find the next three terms of each geometric sequence. So all you're going to do is take, if we take a sub 2 divided by a sub 1, if you take this term divided by the previous term, negative 2 divided by 8, this is going to help you find your R value. So we're going to get R equals 1/4. And if you're not sure, you can check it with another one. You can take a sub 3 divided by a sub 2. So we'd have 1/2 divided by negative 2, which is also 1/4. So you take the next one divided by the previous one to find R. So then the geometric sequence is multiplication. So you multiply by 1/4, multiply by 1/4. So the next three terms, we'd multiply by 1/4, and we'd get 1/8. Multiply that by 1/4, we'd get positive 1/32, and then multiply that by 1/4, and we'd get negative 1/128. So this one is a little trickier, okay? We're still going to do the same thing. So we're still going to say, all right, to find my R value, I'm going to take 2w plus 6 divided by w plus 3. So in order to simplify that, I have to factor out that 2. And then when I have that factored, those will then cancel, and my R value is 2. So my next three terms, I'm going to multiply that by 2. So I'd have 8w plus 24. Then I'd multiply that by 2, and I'd have 16w plus 48. And then multiply that by 2, and 32w plus 96. Those would be the next three terms in that sequence. So we're back to one with numbers. So I'm going to take 11/4. That's it. There's my R value, 11/4. Pretty easy, okay? So in order to do this, I'm going to take 30.25 divided by 11, or excuse me, times 11 divided by 4. And I don't want to write out that decimal. So I get 1,331/16. And then I take that times 11/4. And I get an even bigger number, 14641/64. And then one more time, I take that times 11/4. And $161,051/256. All right. If you want, you can watch me or you can pause this, but let's try this one. Find R. I'm going to take this term divided by this term, so negative 16R plus 32 over 64R minus 128. Both the top and the bottom factor. I'm going to factor out a negative 16 on top, and I'm left with R minus 2. And on the bottom, I'm going to factor out a positive 64, and I'm left with R minus 2. So my R minus 2's cancel, And then negative 16 over 64 reduces to a negative 1/4. So there is my R value. So I'm going to take 4R minus 8 times negative 1/4, and I'm going to end up with negative R plus 2. You're going to essentially divide both of those by 4. Next term, I'm going to have this times this, so I'm going to have negative R plus 2 over a negative 4. Or if you wrote it as R minus 2 over positive 4, that would also be acceptable. And then I have to take this times this for my next one, and I would have negative R plus 2 over positive 16 for my next 1, 2, 3 terms. All right. Next. An explicit formula for the nth term of a geometric sequence is a sub n equals a sub 1 times r to the n minus 1, where a sub 1 is the first term and r is your common ratio. Okay, so those are the two things that we need to write an explicit formula. A recursive formula is based on the terms that come before it. And so we know the terms that come before it, and we can write some form of a recursive formula. Okay, so let's start with this one. A sub n equals, my first term is 8. My common ratio is going to be negative 2 over 8, or negative 1/4, to the n minus 1. There is the explicit formula. Recursive. I have to define a sub 1. A sub 1 equals 8. And a sub n is going to equal negative 1/4 times a sub n minus 1, where n is greater than or equal to 2. This pretty much works for any geometric sequence. You put your first term, and then you put your r times the previous term, and that'll give you your recursive formula. So this number 2 here, first thing I need is my r. So I have 25 divided by 2. So my explicit formula is going to be a sub n equals 25 over, oh, whoops. I gotta put my a sub 1 first. So 2 times 25 over 2 to the n minus 1. That is my explicit formula. And then my recursive formula, I'm going to define a sub 1 as 2. So a sub n is 25 halves times a sub n minus 1, where n is greater than or equal to 2. All right, find the 27th term of the geometric sequence. Well, these numbers are getting worse and worse and worse. If we want to find the formula first, then I can find the term we want to use an explicit formula. So again, a sub n is going to equal my first term, 189, and I need my r value. So I'm going to take 151.2 divided by 189. So 151.2 divided by 189 is exactly 0.8. So there's my r value. So I want the 27th term. So to find the 27th term, I take 189 times 0.8 to the 27 minus 1. Plug that in the calculator. And if it doesn't change it to a fraction, you can round to 2 places unless it states otherwise. All right, find a sub 9. This is like finding the 9th term. So again, I'm going to start with my formula. My first term is 4. I need my r value, so I'm going to take 14 over 4, which reduces to 7 halves. So 7 halves to the n minus 1. So a sub 9 is equal to 4 times 7 halves to the 9 minus 1. Calculator. And this would be approximately rounded to 2 places. All right. Find a sub 12. So I'm going to start with, we have a sub 3 instead of a sub n. We don't have our first term. Well, I'm going to use the formula a sub n equals a sub 1 times r to the n minus 1. I have a sub 3. So a sub 3 is going to go here. A sub 1 is what I'm looking for. I have my r value and I have my n value. So negative 4 squared is 16. And so a sub 1 equals 2. So the formula is going to be a sub n equals 2 times negative 4 to the n minus 1. And I'm looking for a sub 12. So 2 times negative 4 to the 12 minus 1. Big number. All right, little story problem thrown in here. Damien purchased a car for $15,000. At the end of each year, the value of the car depreciates 11%. Depreciates means that it's going down. Write an explicit formula for the value of Damien's car after n years and find its value after 7 years. So the initial value of the car is $15,000. And my common ratio, if it's going down by 11%, I'm keeping 89%. So I'm keeping 89%. So that is my common ratio. And to the nth power. Because after the first year, after the second year, after the third year, that's just going to be an n. So then after the 7th year, it is only valued at $6,634.70. Okay, geometric means. These are terms that are between 2 non-consecutive terms of a geometric sequence. Okay, so non-consecutive means not in a row. So like if you had this one and this one, those are not 2 in a row. This would be 2 geometric means, okay? So they're going to tell you how many geometric means that you have. Write a sequence that has 2 geometric means between 480 and negative 7.5. So you're going to take 480 times your common ratio and get this number, times your common ratio and get this number, and then times your common ratio and get this number. Okay? So I'm taking 480 and I'm multiplying by my common ratio 1, 2, 3 times. So 480 times r cubed, r times r times r, would give me a negative 7.5. So I take negative 7.5 divided by 480, and I get a negative 1/64. And then I take the cube root of both sides. So r equals a negative 1/4. There's my common ratio. So I just take 480 times negative 1/4. And I guess if you need to use a calculator, you can use the calculator, but 480 times negative 1/4 is going to give me a negative 120. And then I take negative 120 times negative 1/4, and I get a positive 30. So my 2 geometric means are going to be negative 120 and 30. All right, same kind of problems presented in a little bit different way. For the indicated geometric means find the indicated geometric means for each pair of non-consecutive terms. So they're going to give you 2 terms that are not consecutive, and they're going to tell you how many means. So I'm going to do like I had already written up on the last problem. I'm going to have negative 4. This one's going to have 2 means and then 13.5. So I'm taking and multiplying by r, and by r. So negative 4 times r cubed equals 13.5. So it's almost the same as the last one. So I divide by negative 4. And r cubed equals negative 3.375. And then I take the cube root of both sides. The cube root is the same as the 1/3 power. So r is equal to a negative 1.5. So I take negative 4 times negative 1.5, and this is going to be a 6. And then I take that times negative 1.5, and I get negative 9. And just to check, I'm going to take that times negative 1.5, and I get 13.5. So again, if you want to pause this and try this, or you just keep listening, it's up to you. But I have 10 and I have 3 means. So I'm going to have 1, 2, 3 numbers in between. 10 and 0.016. Okay. So I'm multiplying by r 1, 2, 3, 4 times. So 10 times r to the 4th is going to give me 0.016. So I divide by 10, and then I take the 4th root, both sides. I already know the answer to this one, but I'm going to show you. So I take 0.0016 to the 1/4 power. The 4th root is the same as the 1/4 power. And so r is equal to 0.2. So to find my 3 geometric means, I take 10 times 0.2, and I get 2. And I take that times 0.2, and I get 0.4. And I take that times 0.2, and I get 0.08. And then just to check, I take that times 0.2, and I get the 0.016 geometric means. So Just like an arithmetic sequence and a series, we have a geometric sequence and a geometric series. There are two different formulas that they give us, okay? The geometric series is the sum of the terms of a geometric sequence. So this formula is if you are given the first term and you are given the common ratio and how many terms that you want. This one is if you are given the first term and the last term and the common ratio, okay? These are both formulas for the partial sum. So find the first 6 terms of the geometric series 8, 14, 24.5 plus ... Okay. So if you wanted to, you could find all the information that you needed. You could find the 6 terms and you could add them up and you'd get the correct answer. Okay. But I know that a sub 1 equals 8. And I know that n equals 6 because I want the first 6 terms. So then I need to find my r. And we've been finding r lots already. I take 14 divided by 8 and I get 7/4. So there's my a sub 1, my n, and my r. So I can use this formula. So my 6th partial sum is going to be 1 minus 7/4 to the 6th power divided by 1 minus 7/4. Using the calculator and being very careful. On top, I have 1 minus 7/4 to the 6th power. And on the bottom, I have 1 minus 7/4. Oops. This should be a minus. And then I have to multiply that times, forgot my 8 in front of here. My bad. A sub 1 times this. So I have to multiply that times 8. There we go. That seems a little more. So 8 goes up front, n goes here, and r goes here and here. This one needs to be in parentheses. If you type it out like this, like I did first, and then take it times 8, you can forgo the parentheses, or if you do it all at once, you have to have 8 parentheses and have all of that in the calculator at once. So this formula again, a sub 1, r, and n. Those are the 3 things that you need. The other one, find the sum of the first n terms, so we don't know how many there are, of a geometric series with a sub 1 equal to 3 and a sub n equal to 768 and r equal to -2. So these are already all labeled. This is the formula that we want. We don't know how many terms that we're finding. So a sub 1 is 3. A sub n is 768. R is -2. And then 1 minus r. Three minus 768 times -2 on top, and on bottom 1 minus -2. And I get 513. So hopefully you can see the difference between these two. It's dependent upon the information that is given to you. All right. Here's one more. This one, you can use the calculator for the summation. So you go math and you go to the summation. We have, again, I'm going to use x, goes from 2 to 7, and then all of this has to go in those parentheses. So it's 3 times 5 to the x minus 1. And you get an awfully big number for that one. last page. Another formula. This is for the sum of an infinite geometric series where your common ratio and the absolute value of it is less than 1. Okay, so essentially it can be between -1 and 1. So we don't care if it's positive or negative. If it's an infinite series and your common ratio, the absolute value of your common ratio is less than 1, this is the formula. You take your first term divided by 1 minus your common ratio. Okay, so we look at this one and we see 9, 3, 1. All right, my common ratio is 3 divided by 9, or 1/3. And if you look, multiply by 1/3, multiply by 1/3, that's working. Okay. So I've got my R, and my first term, my A sub 1 is equal to 9. So the sum of the infinite series, because it's dot, 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 so it means it goes on forever, is going to be 9 divided by 1 minus 1/3. And this common ratio is less than 1, so we can use that formula. Again, if you're going to type it in like that, I'm going to go alpha y equals, and I'm going to do 9 divided by 1 minus 1/3. And I get 13.5. So looking at my R value, I'm going to take negative 1.25 divided by 0.25, and this becomes a -5. Okay, so if you take negative 1.25 divided by 0.25, you get a -5. Because the absolute value of -5 is not less than 1. Okay, that is not true. I can't find the sum. We can't use the calculator if there's an infinite, so I can use this formula. My first term in this case is going to be when this is 4. So I plug in 4 for this one, and I have 4 times 0.2 to the 4 minus 1. I get 0.032. And then my common ratio is right there. That's the base of that exponent. That's my common ratio. So R is equal to 0.2. So to find my sum, I take 0.032 divided by 1 minus 0.2. And the sum is equal to 0.04. All right. R, -5 divided by 10 is a -1/2. And if I look, -1/2, that's another -1/2. It keeps on going. Okay. And my A sub 1 is equal to 10. So my summation, this still fits the bill. It's the absolute value of this is less than 1. So I take 10 divided by 1 minus a -1/2. And I get exactly 20/3. This can be tricky because sometimes you get in the groove and you just automatically take the first two and you move on, you take R, you take A sub 1 and you do the problem. But look at this, 20, 15, 10. This is not a geometric series, okay? This is an arithmetic because you are subtracting 5 each time. And then one more. Can't use a calculator because it's infinite, so we use the formula. My A sub 1, this is a 1. I'm going to use 120 times 0.8 to the 1 minus 1. 1 minus 1 is 0, so I get 120. And then my R is 0.8, so then I use the formula, and I'm kind of running out of room here, but S is equal to 120 divided by 1 minus 0.8. And I get 600 for my series. All right.